Right. Apart from that, does anyone have any updates from your side, from what you've been building, or?
Yes, Chris should be updating. There he is.
Sorry. Yeah, sure. We just completed milestone 1 of our Go node for Fund 12, which is essentially all of the storage systems, meaning tracking the chain database itself, the ledger, meaning all of the updates as they apply, keeping the active ledger state, all of the protocol parameters, tracking through all of the eras, tracking through protocol updates, keeping all of that stuff into storage so it's all available. We have pool registrations and deregistrations being stored, so we have all the relay information and all of that, which allows us to move on to milestone 2, which includes our connection manager, so outbound and inbound peer-to-peer and all of that. So we obviously needed things like the stake pool registrations and deregistrations to be able to fully get to peer-to-peer. Milestone 2 is also all of the node-to-node networking. We've been working on it for a while, but hooking it all together into a single cohesive thing, and attaching it to that storage is essentially that next step. And then node to client is milestone 3, when we can start attaching other things. Oh man. Yeah, it's do you want a Go node? Because this is how you get a Go node.
It's a not so short link, is it?
Yeah, I don't have it off the top of my head. I can go look for it. But I mean, it's easy to find with Blink Labs on Project Catalyst or anything like that. Anyway, so we're getting there, right? Is the idea, and I just kind of want to sidebar a tiny bit and talk about Pragma and Amaru and the Rust node and where they're at, because it's very similar. They have a demo video that they've published on their website. It's not very easy to find. You can go to the Amaru project and click on October. Oh, you got okay. Yeah, sweet. Thank you. You can go to the pragma.io/project/Amaru to go to the project page for Amaru and click on October in the timeline, and there's a nice demo video. That video is doing, sure, just pull it up. So you can click projects, Amaru, right side, and then if you scroll down, there's a timeline, and if you click on October here in phase 2, it'll actually give you the demo video here on the right of, So anyway, there's a demo video for it. They're doing the chain sync and things like that that they're pulling. They've added a lot more validation. So they're doing validation through all of these stages, which is not something that I'm necessarily doing in mine, because we're considering it a data node and expecting you to have a trusted node somewhere in the network that's doing this validation. Eventually we're going to get there, but it's not our primary target. Whereas they're starting with the correctness and the validation.
Sorry, just reminder, Amaru is in what language?
Rust. So this is the Rust node that's being created by Pragma. So this is, the work of the collective work of TX Pipe, the Cardano Foundation, and Sunday Swap, DC Spark, and Blink Labs. Right, is Amaru, and that's. Anyway, so the point is we've got a lot of progress happening along both of those fronts.
Sorry, I didn't mean to stop sharing my screen. I just have this glitch where it freezes and I need to unplug the HDMI to plug it again. I'm doing that.
No problem. So as I said, you can see some of the stuff that they're doing. So they're, as is always the case, we're moving at different speeds. They're ahead of us on the validations side and the correctness side. So we're not spending any time focusing on that whatsoever. And instead, we're spending our time on the network side of it and the actual communication and all of that stuff. So essentially, the idea is we prove out and build out all of the communication factors while they're building out all of the validating and correctness of all of the data that's coming in and out. And then we copy each other's homework, right? So, so TX Pipe is going to be working on the peer-to-peer networking, and things like that we're working on also. So we're able to, like, side by side, essentially work on it and, like I say, copy each other's homework. So that's where we're able to work together in all of these things to try to get us our node diversity. Yeah, in fact, here you go. You can see our laid out milestones. So
yeah, just gonna try to make it a bit bigger. Yeah, hell yeah, crack on. We need diversity, right? We need different tech, and it's amazing.
yeah. And so, like, I can kind of I'll segue a tiny bit into, like, one of our Fund 13 proposals, and then I'll let someone else talk, But so one of our proposals is an archive node. And so something that is very useful and is in use in a lot of other blockchains is the concept of an archive node. And the point of an archive node is to store the chain history, right? All the way back from Genesis and all of that. Well, if you have an archive node, it means you have the ability to have nodes that don't have the full history easily, right? So what we're building is essentially a trusted archive node. And in our Go node, we are building the ability for it to utilize that archive node natively. So we're going to build a protocol for communication between, a validating node or an execution node, a node that, like, follows the ledger rules and the tip, versus an archive node, and allow it to communicate and essentially proxy that kind of data as it's requested from the execution node to an archive node. So the point is you end up with a single interface still, what looks like a normal node, but it's really split into two parts. And the point with this is our archive node, we're going to leverage, like, cloud object storage, which is ridiculously scalable in the number of clients and things like that can be attached to it. And by using this and attaching the two nodes together, essentially you can have more than one execution node that shares a single archive node, because the archive node doesn't actually share the data. It's responsible for coordinating the data, and the actual data is stored on object storage, which is like Amazon S3 or Google storage buckets or things like that. And they are, of course, ridiculously scalable. So the point is if you're a DApp and you're looking to scale really big, and, or you're IBM or some giant corporation that's integrating stuff on Cardano, and you might need a large number of nodes, you can essentially offload the historical data, which is beyond the immutability cliff of the blockchain, right, on these highly scalable object storages. And then our node will be able to utilize that data transparently. So if you request data that the active node doesn't have, it'll proxy it automatically to the archive node, and it'll pull the data from, like, that object storage.
Yeah. So which proposal is that from the ones
archive node?
Sorry. Okay.
We got a bunch of them in here now, huh?
Yeah. Let me just try to
try it in quotes.
Okay.
No, I meant Blink Labs, but yeah.
Okay. Let's try this.
Yeah, idea scale is kind of a little rough sometimes.
Is it all together or?
Yeah, no, that's fine. Yeah, it's 2 words.
Thanks. Mm-hmm.
It should be because, like cloud native archive node, or cloud native archive blockchain archive node, or something like that. Yeah, here it's not even loading right now.
Yeah, I think not sure if it's.
Oh, wait. Okay, Apollo handshake. Okay, so that's it. Whoa, there you go. Cloud native far left. Cloud native blockchain.
Got it. Okay, because I was thinking we can cut this call today, and from the point where you started introducing your progress with milestone 1 or 2, and right. Pitching this, we can push this to YouTube and share it. So hopefully,
sure, I can also always,
for a lot of people.
We can do this with other people and share it too. But yeah, so the archive node here, I mean, like, that's essentially the design of it, and the goal of it is to be able to use the object storage. And if you're running nodes on Cardano now, you know that the storage requirements are about 200 gigabytes and growing, right? And so, like, now imagine you're a company and you need, 32 Cardano nodes, right? So that's 32 times 200 of your disk storage. The active like data set that you really need for UTXOs and things like that is closer to 30 gigabytes. Right. So if you're able to offload that to 170 gigabytes per node, essentially to a third-party storage where you only have to store it once and everyone can reference it, right? Like the cost drops dramatically. So it's even at current blockchain sizes, it makes sense for like large enterprises or corporations that are going to be building large-scale applications, right, to use something like an archive node here. So there's immediate benefits for it, even before the point where like, oh, well, now SPOs need to split or anything like that, right? That'll eventually come, but with how conservative we are on block size, it should take a long time before we get there, right? But other people might have that need sooner. So the idea is we want to be able to provide it sooner.
Great stuff. Great stuff. Yeah, let's try to get this one approved. We're gonna share it on YouTube, and I'm not sure if you have any questions from Roberto, from anyone from Game Changer.
Yeah, anyone have any questions?
Yeah.
Okay, first, congratulations. It's amazing to be here on this point on the timeline where we are very close with, or nearly close to having more node diversity. So congratulations for being part of that effort. It's not easy task. I know it's not easy task. I can read my partner's mind, Martin's mind right now. I bet he's asking in his mind the same as I do. What possibilities are regarding, I don't know, maybe trying to compile to WebAssembly from the node, from the Go node for the browser. Is that something crazy, or you have thought about it?
We've thought about it. That's obviously one of the advantages of us writing stuff in Go is WebAssembly itself is actually just a target for Go, just like anything else. So there is work to be done. It's not like completely transparent. It just magically works, but it works, and it's not that difficult to get to. That's one of the things we have been focusing on with the Go node and Go stuff in general is the cross-platform and compatibility across different things. If you look at most of the things that we build for Linux, Mac, Windows, and FreeBSD even. For both ARM and AMD 64 out of the box, like across the board for like pretty much everything that we build. So that's definitely the idea, is being able to take it, and especially with the concept of the archive node, right? Like it makes it even easier to have things where you have a much more limited data set locally. And some of our ideas is not, I know this kind of comes across wrong, but like not everything has to be trustless. And so what I mean by that is, right, like if you're a corporation and you're building your own application and you want to have wallet access or whatever, right, like it does not necessarily have to use public resources. In fact, most of our wallets today don't, right? Like they use some API or some backend service from somebody else. So the point is you're a company, you want to make a wallet, right? Like you could actually build it where a lot of the node functionality is, in the end user device, as far as the math and the proving and, like those sort of things, because we've moved those node functionalities without necessarily having to have the entire state locally, right? So, the idea would essentially be, being able to confirm data from the back end instead of necessarily having to generate all of it or prove all of it yourself all the time, being able to selectively confirm data.
Great, amazing. And I was not able to watch the properly the timeline, but when are you expecting to having this finished? The node, of course, the archive node. I don't know if it's a dependency.
No, it's not. It's not a dependency. In fact, the archive node is a separate mode of operation for the node. So the Go node in Fund 12 which is the end result for Fund 12 is what I would call a transaction gateway node. So it's a node that will be capable of accepting transactions, validating against its own database. So not necessarily doing like on-chain validation the same way, but validating data against its own database and being suitable for using as a transaction gateway, for wallets or a D app or just like a local app or whatever the heck you want. That's kind of the idea. And then also for DApp developers for the opposite side, like all of the data serving aspects of it. So it implements the UTXO RPC spec. So the same thing as Dolos. We are building the Go implementations of that, right? Like just while TX Pipe does the Rust side. So the idea is to build interoperable stuff, but everybody kind of has like different targets for what their use cases are, who they're, like kind of people that they're targeting. And we are really kind of like going direct for large enterprise type customers by trying to use the services and interface with things that they're used to, right? So again, we understand that a lot of times, like for a large enterprise, they care about trustless when it comes to interacting with each other. But when it comes to interacting within themselves, it doesn't have to be trustless, right? It's perfectly fine with, and in fact, they want trusted control of who has access to what data and this sort of thing, right? So it's like we're building to integrate with those systems. So the Go node, anyway, being usable for like DApp stuff. Probably January, maybe February is about when we should be finishing up with that proposal.
Adrian, you can just jump in, please.
Yes, it's way too formal. But it's a very interesting project. So, guys, are you in talk with Michel Harmonic? Michel, from Harmonic Labs. He was.
Yes, I promote Michele in the whole series. When I talk about node diversity, I'm always sure to talk about Michele and TX Pipe as well as Blink Labs, because we are looking at 4 different types of nodes that serve different functions, and that's really kind of cool.
Great. Well, we are interested in all the nodes that can be ported or adapted to run on the browser for obvious reasons. So great. Keep us in mind if you want some feedback one day or something regarding that use case, because as far as we can go with our small team regarding trying to integrate with such a thing, we will do. We want to. So we're very interested in that. Keep the great work. Thanks.
Thank you.